Hi, in the last video we covered Event Sourcing and CQRS. We talked about why CRUD loses history, what an event log gives you, and why CQRS naturally follows from Event Sourcing. If you haven't watched that one, link is in the description or on top of the screen. Worth watching first. Today we deploy it for real AWS services, real code, a real order following from an API call, all the way through 4 different projections into 4 different data stores. So let's get started. In the last video I showed you that event sourcing and CQRS, they go hand in hand. Here we can see that on the right side, client sends events to the event store keeps those events, and then there's synchronization with the read side where projection consumers retrieve those events, convert them to a readable format, save them to a read database. That data then is served to end client via REST API. Let's see now how it looks on the real AWS implementation. I implemented it this way. So we have a client that is faced by an API gateway, and that API gateway sends write requests to the event sourcing part and read requests to the CQRS part. What happens on the right side? Command Handler Lambda receives PlaceOrderCommand, and then it writes it to DynamoDB table and fans out this event to all other subscribers via EventBridge. This event then is sent to the subscribers, and these subscribers are kept in the read CQRS part of this puzzle. On the CQRS side of this system, we can see a few projection handlers. Those are Lambda functions, and each of these Lambda function is subscribed to the event sourcing event on the EventBridge bus. What those projection handlers do, they convert the events to necessary format and keep them in databases. Every projection consumer here has its own database, mainly those Dynamo databases, for example, inventory stock, order status, and pickup list, the DynamoDB tables, and finance DB is Aurora database. Above that, we have API Lambda that reads data from those databases and serves them to a customer. Let's take a look at it in more detail. Now let's see how it is implemented in the code. Everything that you have seen on the diagram is coded and deployed to AWS using CDK. So we have here a few lambdas. Command Handler Lambda is the Lambda that sits behind API gateway and receives client requests and writes those events to DynamoDB table. So we have, for example, this event mainly coming from the customer, like customer ID and items, and then that event is saved to DynamoDB table and sent to event where it is available for consumption by projection consumers. For example, that is a finance projection consumer. What it does, it receives event from EventBridge and it inserts a revenue entry into Aurora table. This way we have order ID, amount, and currency of the order in a database. And projection inventory, projection order in projection, and projection warehouse, they have similar functionality. They update data on DynamoDB tables, and they have different DynamoDB tables for each. The CQRS pattern doesn't require different projection consumers to have different databases, but just for the sake of the demo, I created a few database tables and a few different databases there. The most interesting part here maybe is the CDK stacks. We have 3 CDK stacks here. That is write stack, read stack, and API stack. Read stack is on the side of the diagram where we read events from the client and save events to table. So we have all the DynamoDB tables and resources defined here, code. When we do CDK deploy, we basically have those deployed for us. And here's the write stack. All the write related resources are deployed here. Basically, those are the storage resources like DynamoDB tables and EventBridge custom bus, command handler function, and separately I have an API stack. It deploys an API gateway that ties those two parts together and basically defines different API resources and what method they use to be accessed. So that is all technology behind that. As the next step, let's see how it works on the AWS console. Let's do a quick demo. As far as AWS, all our flow starts with the API gateway, so that is the API gateway we deployed. The main endpoint where we create orders comes here in the /orders endpoint. We also have a few other endpoints like revenue and get inventory product ID, get order ID, and get warehouse pick list. Also, we have a few DynamoDB tables. Let's see. Here they are. The event store is the event storage database where all events are stored literally without any modification. We just keep the aggregate ID we generated and keep other metadata about the request like payload, timestamp, event type, so on. We have inventory, stock, order status, and warehouse pick list. Those three tables, they are filled with data after an event comes to event store and written to EventBridge, and the event consumers pick those up and update those tables. Let's try writing something with Postman and see how it updates all the way. So that is the event ingest endpoint, and it accepts an event of this type. We specify custom ID, product ID. Let's make the product ID number like something 1000. Name, shoes, quantity 1, unit price 50. Now let's send it. And the event has been sent. We can see it now in the event store table. Let's update it, and one of them is the event that we have sent. Yes, this is this one. And this event was supposed to be picked up by the event consumers, and other databases should be updated. Let's see if they were updated actually. Order status table. Yeah, that is the entry for the custom ID 5 that we sent. So we can see the order status is placed, and we can see the list of items here. We also can retrieve this data by the API gateway, by the way. Let's get the order ID. Order ID is this one. We're going to get an order by ID in Postman. And yes, we have the detailed information about our order. So the API, read API endpoint works. Let's see what else we have here. We also have, where's the finance? Yeah, finance revenue. Let's see the finance/revenue. Yes, we got it. So this endpoint returns data in this format, order ID format, currency, and when it was recorded. This data is coming from RDS database. Before we close, the trade-offs. Because this architecture has real costs and glossing over them would be doing you a disservice. Eventual consistency. The gap between post returning and get reflecting the change is usually under a second, but it exists. For order status, acceptable. For payment confirmation screen where the user is watching a spinner, you need to think carefully about whether this is the right architecture. Projection failure. If the finance lambda fails, network bleep, Aurora cold start, a throttle, the order still exists in the event store. The revenue record is missing, but nothing is lost. You can replay the event and rebuild the projection. That's the safety net event sourcing gives you that a CRUD system doesn't. Schema evolution. Order placed event version 1 is in that DynamoDB table forever. When you add a field in version 2, every projection consumer needs to handle both shapes. This is manageable, but it requires discipline. Versioning your events from day one is not optional, it's mandatory. Operational complexity. 3 stacks, 6 Lambda functions, 4 tables, 1 Aurora cluster, a VPC. This is significantly more moving parts than a CRUD application. The question to ask before adopting this is not, is this thing cool? It's rather, do I actually need audit trails, temporal queries, and independent read models? If the answer is no, a Postgres database and well-structured schema will serve you better and ship faster. Link to the full repo in the description. CDK Stacks, all 6 Lambdas, TypeScript types, everything. If this was useful, subscribe. If you've done something with event sourcing in production, drop a comment. I'd like to hear what the hardest part was. See you in the next one.